All right. And if you've ever tried to work out slopes on a patio or something like that, you know that there's a lot of things that come into play, and I'm going to kind of walk you through it, just an example scenario. This drain, so this patio has got some dimensions on it, and you've got a drain in a certain location, and you need to locate the elevation of that drain to minimize the impact of the slopes around the perimeter. You want to minimize the amount of slope. Your maximum slope here is 2%. So no slopes that are in the yard here could be over 2%. So I'm going to walk you through some of the process to get that. So let's go. I drew it all up, but I'm just going to go back in time. Control Y. So from the door, so the door is fixed. That's your elevation. It's fixed. The dimensions from the door to the drain in this direction are 11.35 in feet. And I just did some dimensions around the perimeter, right? And then draw the starburst corners. These are going to be almost like your valleys. So if you have a slope from here to here, let's draw some dimensions for those two. Let's go back a little bit. So I want to get the dimension of these legs here. These are the perpendiculars to the drain, right? So you have the valleys, and you have the perpendicular to the walls to the drain, right? So in this case, this one's 2.49, and this one here is 1751. And so I start going through the calculations. 0.2% times 16.4. I don't know why I did 16.4. It's 17.51. Let's go forward a little bit. Oh, here you go. 16.4. That's where I picked it up. It's incorrect. It should be 17.5. And then 2% times 11.35. That's going to be 0.227, which is about 2.23, right? So let's just go through and do the calculations here, and then I'll change that one that I missed. So this one here is the one I missed, right? I think that's pretty. Oh, so I go through. Let's go through. I don't want to lose the ability to go back in time, so I can't modify this now. But if you went and did a tools calculator, I don't think that's going to blow anything. Tools. Can't get the tools, huh? Calculator 0.02, that's the 2% times, that's 17.51, and we get 0.35. So control V. Oh, I didn't 0.02 times 17.51 equals, there's your slope. That's your control C. That's the vertical component of this one, right? Anyways, I'm going to put it in there. I'll paste it in later. So the controlling factor is this door. So the maximum slope from this along this line, this vertical line here. Let me zoom in a little bit. This vertical line on the page, but this line, this perpendicular line to the drain, that cannot be more than 2%. If that's 2%, the valleys here will be less than 2% because the run is longer relative to the slope here, right? So to calculate the elevation of the drain, that's going to be the least impact. It's going to have the least minimize the slopes in the whole area. This is the controlling factor. So you go 100 minus the 2.227, and you end up with 99.773, which is just 99.77. That's less than a 16th there. So that's the elevation of your drain. I didn't write that down correctly, but that's it, 99.77. Now, from there, you're going to take that 99.77 and you're going to add, what's the I didn't do it that way, but 2% of 3.65 is 0.07. So let's just do that. Let me change these here to this one, right? The one with Control V, right? And then we have the proper, so from the drain, we're gonna have to go up 0.07. So we're gonna take the drain height of 99.77, which is determined by this line here from the door. And then we're gonna go to the calculator. So 99.77, I'm gonna copy that, plus, I'm gonna copy that, Control C, we're gonna use that a lot. So I'm gonna put plus 0.07. That's this elevation, the difference in elevation at 2% from here to there. And that's gonna be Control C equals, Control V equals, so I'm gonna just paste that one, Control C, right there. So this elevation here is gonna be draw, let's make it red, we'll go in the color of the rainbow. And we'll make that a little bigger. And this will be red. Control R. So this is the calculation. Let's make that red too. For this point here. So 99.84. So for this line that's along this wall here will have to be so V, that'll be red. So it's going to be sloping from 100 to 99.84. So it's about 3/4 of an inch sloping down. And then you'll have the 2% here too, right? And then this is longer. So honestly, I'll probably leave this line from here to here level to this one because, well, it's going to be 0.05, right? 0.0498. 0.05. So since it's a longer run, it's actually closer in elevation to there, so you could raise it up to the same as this one and it would be fine. Or you can just prorate, go, let's find out what that is. So 99.77, tools, plus 0.05, and then compute 99.82. So you could go 84, 83, 82, just if you wanted to prorate it for that little bit. But I would probably just leave it at 82 because at 82, you're it's less than 2%. It's not getting greater than 2%. Just to simplify things, you could just use your level to come over there. All right. So let's just make that the same as this one, 99.84. And then we're going to go from, we don't know what the corner is until we know what this is, because this is going to be, we can probably make this, well, let's go back here. So on the building, with the doors at, we're going to make that level just because there's stuff underneath the house, there's stuff on the house, hose bibs and vents and things, right? So, and we're going to make that level. So let's just make that level. Go to red. How about we make it orange? All right, and so that's 100 T100. All right, and then we're going to go from the drain, tools, 99.77. Plus 0.35, 0.35, enter, we end up with 100.12. Tools, and then we go to drain, here we're going to be green, tool 100.12, T, EL, 1, 2. So even though it's higher than the door, it's still, everything's still going to drain to the, so you're going to actually be going uphill here. And then in this case, we can just leave it level and would slope from here to here, or you could do both. You could slope it. Let's find out what the 100.12, we know this is 99.84. Right there, T. Or 83, I think it was, came out to, or 99 point, that doesn't sound right. 77 plus a half, yeah, there you go, 84 would be 82, right? If we went 2% to there. And then, so from there to there, pretty much what I think I would probably do is to, this is a longer run, and you just got to pick. You could make this, you could make from this point to this point. Let's draw the point, and we'll make it blue. All right, so you could, this one here sloping up, and then you can make this one's going to start sloping down to here. You could slope it from here to here and from there to there by prorating it. So you go 17, and then this dimension right here is 3.65. So you go 3.65 divided by 17.51. And compute, let's do that, Control C first. Compute, Control V equals, and I'm going to paste that right down there, Control C, Control V. And what we did was we took the ratio of this length to this length. So we're going to prorate that. The difference in elevation from here to here is going to be 0.28, 20% of that, right? So let's do 100.12, 100.12 minus 99.84. Copy that, Control C, compute, Control V equals, Control C. And then you wouldn't have to Control V. You could, like I said, you could just take this and make it level and slope that a little harder. But let's just prorate it. And then 0.28. So it's going to be 20% of 0.28. 20%, the ratio of this leg to this leg, times the elevation, right? So you're going to get the 20% of 0.28. So 0.21, which is, this rounds up to 0.21, times 0.28. Control C, compute, Control V equals, and then Control C again, Control V. So these should probably go in this order, right? So we calculate the ratio of the length of the legs, then we calculate the total height, and then we multiplied that ratio times the height, and we get 0.05. So we'd be going 0.06 from here to here. So the elevation of this one, T E L 100.12 minus 0.06. Equals, that would be 100.06. Alright, 112.06, Okay, so there you go. So now you have the elevation of this point right here, T elevation backspace right there. And then you'd snap line from there to there, and that would probably be probably the best to sort of prorate it, since this is going up so hard. It's going up. It's not hard. It's to less than, I don't know, what is the ratio? What's the percentage of what it looks like over here? 112. So it's going up about 1.5 inches, and then it's going down 3/4. I don't know. I think I would probably leave it alone, and put the more slope here. But to minimize the slope, you will want to prorate it. Because then if you stack something up over in this side, it's going to be less impacted by the slope than, so everything's minimized if you prorate the corners. And that's that's some stuff about running slopes. That's pretty typical. You'd have a scenario something similar to this. And if that was the case, like I said, if this is 2% and that's 2%, all these valleys would be less than 2%. And you can have running drains like this. Like I said, you could have an area where you're actually going up higher than the control point to minimize the slopes. And I hope that helps you in your career. And thanks for watching. If you like these videos, just let me know. I can run videos. If you got questions that have been bothering you for many, many years, I'll try to put them up, because I've been doing this for many, many years. It's not the kind of stuff you learn in school, so I'm trying to give everybody a chance to, have exposure to some of this stuff. And I think total stations and theodolites and transits and different types of instruments, even into GPS and stuff like that. I can get into that too, but for now, like I said, I hope this helps you in your career. And if you understand this, please try to, teach others, or give them an avenue that same as you. Like, you've managed to get this from here in the field, maybe you could show them, or you could direct them to this channel where they could learn this stuff and maybe ask some questions, and I'd be happy to try to answer those. Thanks for watching. Have a great day.